This is how to wire an XLR cable. 3 metal pins, 1 balanced signal, and a wiring order that turned a noisy stage into a dead quiet one. So this is how to wire XLR cable properly, end to end. The 3 pins, the balance trick, male and female, the solder joints, and the one rule that ties both ends together. By the end, this finished connector will make complete sense, and you will be able to wire one yourself. Start with the connector. An XLR has 3 pins, and every pin has one job. Pin 1 is ground. It connects to the shield, the braided mesh that wraps around the 2 signal wires and blocks interference. Pin 2 is hot. That is your positive signal, the plus side. Pin 3 is cold. That is your negative signal, the minus side. 1, 2, 3. Ground, hot, cold. Say it once, and it sticks. Inside the cable, you will find exactly that. 2 insulated conductors for hot and cold, wrapped in a copper shield that becomes ground. 3 connections. That is the whole cable. Now the clever part. Why does XLR stay clean over 100 feet when a guitar cable hums at 10? It is called balanced audio, and it lives on pins 2 and 3. Here is the trick. Pin 2 carries your signal. Pin 3 carries the exact same signal, flipped upside down, out of phase. As that cable runs past power lines and lighting rigs, it picks up noise. But here is the key. The noise lands on both wires equally, the same on hot and cold. At the far end, the receiver flips pin 3 back and subtracts the 2. The signal doubles up. The noise, being identical on both, cancels itself out to nothing. That is the whole magic. 2 wires, 1 flipped, and the interference just disappears. So which connector goes on which end? XLR comes in 2 halves. The male connector, the one with 3 pins sticking out, is the output. It leaves a microphone or a DI box or any source. The female connector, the one with 3 holes, is the input. It plugs into your mixer or your interface. Signal always flows from male into female, and the pins map straight across. Pin 1 to pin 1, 2 to 2, 3 to 3, every time. Now the solder joints, where the wire meets the connector. 6 steps. 1. Slide the boot and the strain relief onto the cable first. Before anything else, forget this, and you will be unsoldering it later. 2. Strip the outer jacket, fold the shield back into a single lead, and strip the 2 interconductors. 3. Tin every tip. Meld a little solder into the shield lead and both conductors, so they take fast. 4. Tin the 3 solder cups on the connector 2. 5. Now join them in order. Shield to pin 1. Hot to pin 2. Cold to pin 3. Touch the iron to the cup, feed the wire in, and let it flow. A clean, shiny joint, not a dull blob. 6. Slide the strain relief down so it clamps the jacket, screw the boot back on, and you are done. Here is the one rule that ties it together. Wire both ends of the cable exactly the same. Pin 2 to pin 2. Pin 3 to pin 3. Pin 1 to pin 1, both ends. Do that, and you have a normal balance cable, the kind that runs a mic to a mixer or links 2 pieces of gear. Never cross hot and cold between the ends. Flip pin 2 and pin 3 on one connector, and you flip the phase of the whole channel. It is a subtle, maddening fault. It thins your sound and fights every other mic on stage. A few things separate a cable that works from one that works everywhere. Phantom power. Condenser microphones need power, and the mixer sends it, plus 48 volts, straight down pins 2 and 3. Because it rides equally on both, your balanced signal ignores it completely. But a miswired cable can short that voltage. So wire it clean, and never plug or unplug a mic while phantom power is still switched on. The standard. Pin 2 is hot. That is the official AES convention, and every piece of pro gear follows it. Keep pin 2 positive on both ends, and everything stays in phase. An XLR is not the only balanced connector. A TRS jack, tip, ring, sleeve, does the same job on a 1/4-inch plug. Tip is hot, ring is cold, sleeve is ground. Same 3 rolls, different shape. One note on safety. This is low voltage audio, not mains power. The cable is safe to handle. Just mind that phantom power when you patch. Everything you have seen is drawn in a free editor that runs in your browser. No install, no login. The idea behind XLR is the idea behind any circuit. A signal needs a complete path, out and back. Here is a source, a wire, and a load. Break that loop anywhere, and nothing flows, exactly like one cold joint on pin 3. Open the symbol library, search for connectors, jacks, or any of 400 parts, and drop them on the canvas. This is the honest way to learn wiring. Stop watching, open a blank diagram, and build one yourself. So here's the whole thing in one breath. An XLR cable is 3 connections. Pin 1 ground, pin 2 hot, pin 3 cold. 2 and 3 carry the same signal. One of them flipped, so noise cancels and the audio stays clean. Male is the output, female is the input. Solder shield to 1, hot to 2, cold to 3, and wire both ends the same. Get those 3 pins right, and every XLR cable after this one is muscle memory. Open Circuit Diagram Maker.app, grab the symbols, and draw it yourself. It is free, it runs in your browser, and the link is right below. Subscribe if this made XLR wiring finally click, and I will see you in the next one.